Welcome back, Science 10. This is the 13.8 section from the CD4 booklet. So 13.8, the hydrosphere. So here we look at the water cycle and a few other things as well. So here, as the glacier figure 1 slowly melts each summer, the released water joins water from melting slow to form fresh water streams, rivers, and lakes. But snow, ice, water, and rivers and lakes and water vapor in the atmosphere make up only a small portion of all water on Earth. Most of the water found is in oceans where the water is so salty that we can't drink it unless you go through drastic filtration procedures. So of course you can't drink ocean water. It would have to be filtered. So of all the Earth's water, both fresh and salt forms is what we call the hydrosphere, so as indicated in this diagram. So out of that, the water distribution in the hydrosphere, what water can we actually drink quite easily? If we take a look here, 97.5% of all water on the planet is salt water, so right off the bat, we can't drink that. Just this little sliver right here represents 2.5% of all the fresh water that we can actually drink on the planet. Now if we take that sliver and blow it up, 87.3% of that fresh water is locked up as glaciers or polar ice caps. Underground water, 12.3%. The actual surface water that we have and water vapor in the atmosphere only make up 0.4%. So if we take this little sliver here, which we could drink, we can see 90% is in lakes, 9% in the atmosphere, and 1% of this section is in rivers. So you can see it's just a really tiny sliver of what we can actually drink on this planet. There's water everywhere, but only an extremely small percentage can actually drink. So this paragraph just talks about that. Most of it's in ice caps, glaciers. So if you were to take, in fact, if we represent all the water in the world as 1 liter, so you can imagine at 1 liter of water, then all the fresh, unfrozen water in the atmosphere, lakes and rivers, would be less than 1 drop. That's the amount you can actually drink. With its vast freshwater supplies, Canada is one of the luckiest countries in the world. Our population is just 0.5% of the world, and yet we have 10% of that little sliver of water which is actually drinkable. It's kind of scary stuff. The water cycle. Now you would have taken this in earlier grades, I imagine. So of course water in oceans, rivers, lakes, or on the ground gets heated up. As it gets heated up, it expands, it rises. When it rises up to a certain point, it cools off and it condenses back into precipitation, be it rain, hail, or snow. The hydrosphere and the human habitat. Of course, fresh water is vital for human survival. In the past, people tried to live near fresh water sources in order to survive. And of course, even today, some of the larger urban centers are on the edges of vast water supplies. Okay. That's really this whole section right here, the hydrosphere, the water cycle that you've taken before, plus this section here indicating how much fresh water we can actually drink. Before we go to the questions, though, what I'm going to get you to do is this little activity here, evaporating salt water. When salt water evaporates, does the vapor carry the salt with it? Okay, so we're going to get some salt water and let it evaporate and see what happens. So you have little petri dishes, which you'll find at the front of the room. Maybe do some groups of 2 or 3, put masking tape with your name on it underneath the dish so you know whose it is after. Add a small amount of table salt to a dry evaporating dish or saucer and use a balance to measure the combined mass of the dish and the salt. Okay, and by the small amount, I just simply mean a scooper tip. Okay, add water to the dish and stir the mixture until the salt is completely dissolved. Place the dish in a safe place and allow water to evaporate completely. This will take several days, and then measure the mass of the dish after. So, dish and salt before, then we'll add water, evaporate the water. Does the salt go with the water? We'll see, because if the masses are relatively the same, then that means it didn't carry it. So it'll be kind of a fun thing that we'll do there. The questions I want you to do for this section, in your own words, write a definition of the term hydrosphere. Number 1. Number 2, explain why fresh water is more important to human life than salt water. Kind of talked about that already. 4, a glacier may be thousands of years old and yet is considered to be fresh water. Explain why. So does the word fresh mean new, or does fresh imply something else? 5, here is a little poem here. It's about a sailor on the ocean. Explain what you think it means after looking at what we've just looked at with this section. As the world's freshwater supply becomes increasingly limited, people in some countries suggest more schemes to obtain fresh water. One suggestion is to tow icebergs from the North Atlantic Ocean near Greenland through the Mediterranean Sea to the Middle East. Speculate about some advantages and disadvantages of this scheme. And yeah, that is the last question there. So 1, 2, 4, 6, and 7. We'll see you again.